These are the working backwards ones. We have a volcano graph and a Batman graph, and we want to draw the original graph as best as we can. Maybe we'll even come up with the equation. First of all, if there are asymptotes, the asymptotes always match up with x-intercepts. So, on this graph, I would know that I have an x-intercept at -2, 0. And then I'm going to do some estimating. It looks like, I don't know, it looks like that point is at -1, 1/2. And it looks like this point's at -3, 1/2. I am estimating these, so I can't be, unless, like, part B, they actually label a point, we'll be able to say 100% accurate, we know what the equation is. It could have been at 4/10 instead of 1/2. We might be a little bit off. But if it were at -1/2, then the reciprocal, and the reciprocal of a fraction is just flipping it. Does it make sense that the original point would have been -1, 2? And we would have had -3, 2. And your parabola would have opened up like this. And once you have a parabola, you could write it in vertex form. It's going over 1, up 2, so the a value would be 2. The vertex is at the vertex is -2, so you'd have x plus 2, and then you wouldn't have to write +0, but you could. But now we've got the equation of that parabola. The second one, part B, is going to be even more easy to do and more accurate. First of all, this one has 2 vertical asymptotes, -1 and 1, so that means we're going to have an x-intercept at 1, 0 and an x-intercept at -1, 0. And 0, 1/2, when I do the reciprocal of that one, I would know I have 0, 2. So there's my parabola opening down, and again, over 1 down 2 would be a -2 out in front, x plus 0 squared plus 2. Wouldn't need those brackets around the x. But I just started the bracket because I thought I might have to do x plus or minus something, only to realize that it was just an x. So your last question to circle in your book, number 9.